Welcome back, everybody, and welcome to the session before our lunchtime interval, titled Real-Time Topology in the Heart of Intent-Based Network Automation Solution. This session will be given by Teemu Nukkonen, Service Architect at Elisa. Welcome, Teemu.
Thank you, and hello to everyone. Before we go into the actual topic, allow me to introduce myself and also talk a bit about the company I represent. So yeah, I'm Teemu Nukkonen, architect at Elisa. I've been working there for the last 3 years, or almost 3.5 actually. I am very much a software-oriented dude. So if you were expecting a speaker with hardcore network background, I'm sorry, you will be disappointed. But the time I have spent in Elisa, I've been working with the fixed network automation solution. So hopefully you find my presentation interesting, regardless of my unorthodox background. So briefly about Elisa. First and foremost, Elisa is a network operator, and we have been that for quite some time now, as the company dates back to 19th century. And at different stages, Elisa has been a pioneer in almost every aspect of telecommunications technology. And that's sort of a bold statement, but actually true. And currently, we are at the front line of 5G deployment. I don't want to spend much time here, but I'll quickly share a few key indicators from last year. So market in Finland is highly competitive, but we are a leader. And we are also doing pretty well in Estonia too. And we have around 5,000 employees, so we are not exactly a startup anymore. And by the way, significant amount of those employees are actually software professionals. So we are quite capable of doing in-house development too. This figure is interesting as it illustrates well the mobile data and actually also data usage in general in Finland. And the trend is ever growing. And I think the actual mobile data usage in Finland is pretty equal to, for example, Germany. Germany just has 10 times more population. So we don't have the muscles. We need to be clever instead of using brute force. But with automation, we have been able to keep CAPEX and OPEX flat. And since I mentioned that automation, we have been doing it for some time now. So for us, it is not just a buzzword that we found yesterday. During those 10 years, we have, for example, automated our network operations center and started to optimize our radio network with the machine learning algorithms. And one of our latest developments in this field is the acquisition of a company called Polystar. Polystar offers excellent service assurance tools like Calyx and fits very nicely together with our previous development with Elisa Automate brand. And now, bear with me. I shall put my marketing hat on for a moment. So we don't just develop tools for ourselves. We also offer them to others. And everything is, of course, battle tested in our own network. And together with Polystar catalog, we actually have a pretty neat set of automation tools available. And what we offer from Elisa Automate is a virtual NOC for service assurance. We have automation engine, which is mainly focused on radio access network optimization. And then we have a Profo fixed network automation tool for transport networks. So that's actually my topic today. So let's focus on it. Like I said, we sell it to others, but today I'm going to talk about how we run it in our very own network, how it works, how we use topology, and what it has eaten lately. So what do we have? We have that real-time topology that I mentioned. And honestly, when I joined Elisa, I thought every operator surely have something like that. Apparently not quite so, but let's get back to that soon. We have multi-vendor support, which has been one of the main drivers for us. We have zero-touch operations, and not just the day one configuration, but full automation from factory setup to operational service. We are live and kicking. We have been running this stuff in production for about 2.5 years. And with 5G rollout, I mentioned earlier, this has been a huge success for us. There has been a need to increase fixed access network capacity, and we have been able to reap huge benefits by automating a great chunk of related manual work. And as a sort of an additional bonus, we can also do automated software upgrades for selected devices. But how do we build the stuff? Well, using modern hand-picked software stack and platform. We rely much on Apache Kafka. We write microservices, mostly with Kotlin and Golang. We use Neo4j, Elk Stack, and for example, Micronauts. Everything is built with cloud-native approach. And within Elisa deployment, we rely much on Kubernetes. And you may notice that there is nothing telco-specific in the stack. You could build, for example, a web shop using the exact same set of tools. And that's kind of the point of our development approach. Select the best possible modern tools for a task, and do not hesitate to throw out something that is not performing. In other words, don't produce code that will be legacy next week. Agile approach. This has proven to be a real winning ticket for us. Build just what is needed and exactly when it's needed. Start with minimum and try it in production, actually. So no 5-year architecture plans or design committees. Fast cycles from design to deployment. In fact, we usually deploy something into production on daily basis or even multiple times a day. No need for maintenance breaks or once in a year releases or requirement to update the whole system in one blow. Each service lives its own life. And then now, don't get me wrong, standards, collaborative initiatives are great. Loads of good stuff coming out from example from OpenConfig, TM Forum, or ETSI. And we keep monitoring that stuff very closely. But I think the fact is, if you wait till the world is ready, you will have to wait forever. So why not to start building the automation today? Because basically everything what is needed is already there. Another thing is real automation. Our target is to build actual automation, not to offer yet another tool or script for network engineers. And I really would like to embrace this, as I would like to embrace the event-driven approach. So if you remember one thing from this presentation, I think event-driven approach for network automation might be a good candidate. It has been one of the enablers of the Agile workflow for us. We like to talk directly to devices, and this supports that Agile approach as well. So we don't have to wait for third-party support for feature X or Y. And that real-time topology, all of the above, would be a lot harder without it. And traditionally, you have nothing like this. But it is really hard to get the automation like we are building to work without it. And that's why we have invested a lot of for the implementation and modeling We collect the data mainly from devices directly, but can also use EMSs. And we store the data in the graph database. And the graph itself is divided into multiple layers. Regarding the benefits, the data is always up to date. This is huge. Enables intent-driven automation. So basically, it's a requirement for our work. Makes architects' life easier. Absolutely. We have one source of truth available. And last but not least, enables automation and service assurance possibilities for future. So those might be completely out of the Profo scope, but the possibilities in that area are huge. Why graph? Why not relational database or something else? I think first and foremost, because network topology is a graph. And it allows us to model and store the data as it is in real life. So no normalization or trying to fit round peg into square hole. Easy to extend model. This fits really well together with our agile approach. And the query power. With graph database, you can rather easily write deep and complex queries without performance hit. And I'm not saying that you can't do this with relational database, but it is just a lot more complex than with the graph database. So how do we ingest the data into a graph? Mostly directly from devices. We have an army of tiny custom-made collectors that can be auto-scaled. And collectors are based on protocol or vendor in question. The data is then pumped into Kafka, and after that handled with the separate adaptation layer and performance writer. And this can be also deployed completely separately from the rest of the solution. Few words about our Zero, that's our service activation philosophy. So we try to keep things vendor agnostic as much as we can, and then just use a separate, should I say, mediation layer components. And as I already mentioned, our target is to offer APIs for machine-to-machine communication, but of course, they can be utilized also for other types of communications too. Intent-driven, what does it actually mean? I've seen all kinds of explanations. For us, it simply means that we have a minimum information required by our northbound APIs, and with the help of topology, we are able to convert those requests into actual network configuration. So we are not requiring user or some other system to fill in the template, but we do that by ourselves within the help of topology data. Also, we are not using much templates, as template languages are usually very poor alternatives to a full-blown programming language, but that's another story. Then something about deployment options, which should not be underestimated. So we run most of the services in environment, which is easily accessible by our development team. And we currently run things in our own data centers, but this could also be a public cloud. What our architecture allows is split deployment, where we can deploy small proxy components closer to network elements. For us, this makes the security issues much easier to handle, and at least I sleep my nights much better. It also allows much flexibility to our developers and the whole DevOps model that we are following. Then regarding where we actually deploy, I would say pretty much anywhere. So although I would like to emphasize the importance of a modern container orchestration platform, in other words, use Kubernetes if you can. We can deploy all kinds of environments. Also, you don't need to deploy all or nothing. Services can be separately picked, and Kafka acts as a glue in between. And all of this is something that I'm personally pretty happy about. At this point, I think you may ask why. Why did you choose to do this? There is this product X or project Y available. And I think the reasoning goes like this. We looked really carefully into what is available and also did some POCs. But we could not find anything that we could have been completely happy with. And we really wanted to have that topology. And although there are some excellent solutions in the market, none of them were quite what we were looking for. Also, the development and deployment flexibility seems to be something that is hard to find. And all of this combined, we really couldn't find what we wanted and thus decided to start our own development. And I must say that we haven't regretted so far. You may also ask, what about collaboration with some other tools? OwnUp, for example, or for example, standard interfaces or another controller. Well, naturally, we don't want to paint ourselves into a corner. Our architecture allows us to add existing pieces into mix whenever it makes sense. Or, for example, we could act as a third-party controller for existing system. And also our in-house deployment. We are not trying to do everything by ourselves. We are offering interfaces, for example, our existing planning systems. And also, we recently made a POC with Telefonica, where instead of talking directly to devices, we used their iFusion interfaces. And of course, there is more to come. We have loads of interesting stuff in our roadmap and backlog. Some might question, is this true SDN and how about the SDN? I would say that this is automation and it makes no difference if you have, for example, virtualized network functions in the other end. We have ways to adapt. So if this sounds interesting, please contact our sales. Let's see what we can do together. Or if you have technical questions, just contact me directly. I'm happy to answer. Also, I would like to briefly show this, as I mentioned that Telefonica POC previously. So I'll briefly introduce what we did together. So we utilized public cloud in our deployment, AWS in this case, and we used Telefonica Lab environment. We collected the topology data using their iFusion APIs, implemented use cases for network creation and service provisioning. And this was an excellent cooperation for both of us. It allowed Telefonica to test drive the iFusion and us to verify that our solutions work in other operators' network too. But I think I have almost used the time I have. So thank you for listening, and I'm happy to answer if there are any questions. And like I said, please do not hesitate to contact me if you have something to ask. So thank you.
Thank you very much, Timo. We're not getting any questions through at this present moment. If we get any questions, I think, Timo, are you going to be at the event for the next day and a bit to answer any questions that might come through?
Yes, I will be available.
Fantastic. Brilliant. Well, thank you very much, Timo. Much appreciated. And hope everyone goes and enjoys the very